Cool. All right, so things you want to really focus on when you start talking about these. We did inverse trig functions last time. The difference between inverse trig functions and a substitution problem, right? So you come across this guy. That's kind of what I want you to focus on tonight, or today, or whenever today is. I guess it's today. If you had this fella here, and you're like, no, awesome. I feel like you, because right off the bat, you're like, it's a function in a function. I agree, it is a function in a function. That's right. But if I did this, oops, minus t squared. Du, of course, is negative 2t dt, which means I have, what do I have? Well, I've got a 4 out here, right? Am I right? Am I right? I feel like I got a 4 out front now. Hey, look at that. I've got a half of a du. A negative a half of a du, yes? And now, this is just u to the minus 1/2. And there we go. And that's a perfectly good substitution problem. Now, while we're at it, let's just for fun, I guess, I feel like, go from like 1/4 to 1/2 or something. Because why not? And so if you do this, you're like, if I put a half into here, 1 minus a half squared is a quarter, which is 3/4. And then 1 minus a quarter squared, which is a 16th, will be 15/16. And so when you do this, if the antiderivative of this would be u to the 1/2 times 2. And so if you plug that in, you end up with negative 4. And then you get the square root of 3/4 minus the square root of 15/16. And that'd be your answer. Okay? But again, why? Well, because we had a function in a function, and most importantly, the derivative of our inside function is in our problem up here. See that? That's huge. But on the next problem, and I got to pause for one moment, please. Oh, poop. Now, so on this other problem, you're like, oh, okay, well, this is a very similar problem, Mr. Groom. It is. Maybe I write it like this so I don't freak you out. Or maybe this does freak you out. I don't know what it does. Like, oh, it's a function in a function, Groom. I know. U is this. Oh, dear. There's no t dt. Now, if it was just a 2, friend, Lord have mercy, we can make a 2 into a 3. We got that. But you can't just randomly pop up a t. You see the difference? In this case, this cannot be substitution. This guy right here, as we all know, because we went home and studied it, we know that this feller here is simply arc sine of t. See that? That's it. That's all. Because again, this will not work. That's problematic. Okay? So again, that's a huge concept to think about. Starting next chapter, we're going to do some more with this. You're going to see it pop up again and again and again. And you're going to see one kind of like this one. 2t plus 1 over t squared plus 1. And you're like, oh, sweet. I'm going to do a function in a function, man. It's a bad idea. Well, how do you know? Well, I've been around the horn a few times, pal. What I would prefer you do, if it was me, I'd prefer I break it into 2 pieces and integrate them individually. Oh, this is my boy. This is arctan, you big dope. Arctan t. You darn right it is, pal. Oh, dude. Let's let u equal t squared plus 1, again on just this fella. Then du would be 2t dt. No friggin' way. Because this ends up being 1 over u du. And the antiderivative of 1 over u is ln of u. So ln of t squared plus 1 plus arctan of t plus, oh, poop, ln of t squared plus 1. Notice I used the woohoo, what you call it's the absolute values. Don't need absolute values in this case. Why? Because t squared is positive, plus 1 is, that's right, positive. And so as a result, I don't need them, but I'm going to go ahead and keep it there just because that's what the cool kids do, as they say. Okay, do a couple more of these that require a little more brute force because, well, I'm a guy that cares about the children, and not in a weird way. Just I care about the kids. It's cool, Mr. Groom. Nope, I lied to you. No, actually, no. Let's do that one. Go away, you hippie. There we go. Nice. And you're like, Groom, why tease today? Because I like it. There you go. Now, again, if you were to do a substitution on this problem, you're like, oh yeah, like u is t squared plus 4. That's a terrible idea. And if you try that, you'll end up with a 2t dt. Well, there's no freaking t's, bro. You're like, Groom, this looks an awful lot like, especially if I bring the 3 out front, this looks an awful lot like arctan. Oh, it does. Except for it to be arctan, one must be doing t squared plus 1. This is arctan. You with me? And so we don't have that, but we can make it. And so what we're going to do is we're going to factor a 4 out of those fellers. And so we're going to end up with, well, listen, if I take a 4 out of 4, we get 1, obviously. But if I take a 4 out of t squared, well, I get t squared over 4, obviously. And then there's a 4 on the bottom. Now, algebraically, that's 3/4. And now I am left with this guy. Now, t squared over 4. Hey, could I rewrite that as something squared? And the answer is, well, of course I can. So that's 1 over t over 2 squared plus 1 dt. That, my friends, is arctangent. Okay? We can do this problem. Now, the thing to remember on this problem is you're like, oh, yeah, but I feel like you have to substitute this because, again, it's a function in a function. So u is t over 2. du is 1/2 dt. Well, I don't have 1/2 dt. I just have a dt. So I have 2 dus. So I have 3/4 times 2. And now I'm going to be the integral of 1 over u squared plus 1 du. Well, that is 3/2 arctan of u, but u is this fella. Okay. Isn't that cute? Isn't that almost fun? Groom, it's not fun. Okay, sure, fine, Kalian. It's not fun. Still love you. You're great guys. You're just swell people. Just love having you in class, etc. Even though you're kind of party poopers. Now, let's try another one just for fun. Again, you can slow down. Miss Brownlow, run us back. You can tell her that if you need to. Be nice about it, though. She's a super swell gal. 7 over... Oh, yeah, here we go. Squirt. 1 minus... Oh, that would be diabolical, Mr. Groom. Diabolical, I say. Sure. Who cares? You're like, oh, Groom, it's a function and a function. U is this. Oh, I got this. Oh, poop. I don't got this. There's no T on top. Rats. Oh, that's right. It's arc sine. You with me? It's arc friggin' sine. Now, the key to remember is we must write this. We must beat this thing into submission. It must look like something squared. Well, our something is 3t. True dat, homies? True dat? So u equals 3t, du is 3 dt. I don't have a 3 dt, I have a 1 dt, so I have 1/3 of a du. And then it's du over 1 minus u square rooticated. And of course that is baby arc sine, dog. Arc sine of u. Huzzah! It's almost fun. I say almost. I mean, let's be honest. It's not that fun, but it's okay. Oh, yes. Now, there's another little rule that we neglected to talk about. We know the integral of e to the x is, of course, e to the x. I'm my own grandpa. But what would happen if you had 3 to the x? I wonder. Let's ask Betsy. Oh, Betsy. Desmos.com. 3 to the x. That's hot. Now listen, friends. E to the x. Yeah, they're almost the same, dog. They're almost the same. And you're like, well, okay. So what would the derivative of these be, right? So we've talked about this. The derivative, well, you're like, well, it should be pretty close to itself. Right. So listen, let's go back in time and let's talk about this. In order to do the antiderivative, I better know what the derivatives are, right? And so let's do this. Let's suppose y equals just any old b to the x power. Groom, I don't know how to take the derivative of that. What do you mean? Well, it's up here in the exponent. What do? I know. Let's take the natural log of both sides. So it's going to be x ln of b. True dat? Now, if a fella were to take the derivative, remember this is using implicit differentiation at this point. What's the derivative of the natural log of y? Well, it's 1 over y dy dx. And what's the derivative? Now remember, ln of b is just a number, like 6 or 12 or something, right? So this is like 12x or something. Well, the derivative of 12x is just, 12, right? Now, check this out, homie. To solve for the antiderivative, solve for the derivative, I would just take y times the ln of b. But y is what? Well, it's b to the x. See that? Right there. So you're telling me that the derivative of b to the x is equal to b to the x ln of b. Oops, ln of b. Sorry, ln of b. It's exactly what I'm saying. Oh, that's interesting. So you're saying that the antiderivative of b to the x ln of b is equal to b to the x plus c. That's exactly what I'm saying. But wait a minute, Mr. Groom. What if I didn't have this guy? What if it was just b to the x? What would the antiderivative of that guy be? Well, I feel like it'd be b to the x, but we'd be missing this number. ln of b is a number like 12. We'd be missing it. In other words, we'd be not as big as we would have been because we'd be not as big. And so it'd be over the ln of b. Now you're like, does this work for e, Groom? It sure does. Because the antiderivative of e to the x is e to the x over the ln of e. But the ln of e, last I checked, was 1. So there you have it. Now this right here is a formula that you need to know. To be quite blunt with you, I often forget that formula because I don't use it a ton. But I know that I can conjure it up in the middle of a test. Let's say I'm in the middle of a test doing something and I'm like, oh yeah, I got this. Yeah, I got this. We got this. Not hard at all. Piece of cake. Okay? And it makes my life, just that much easier to do. Okay? Just a minute. I feel like I was forgetting something. I don't want to forget it. but I feel like I'm forgetting something. Let's do this one for fun, although I think it's on your assignment, and if it is, I apologize in advance for doing it for you. I feel awful. E to the x. McPherson Green, which problem is it? If you can't figure it out, that's a you problem, pal. Chase. Freaking Tyler. Now, what do you got here? Well, I think it's a substitution problem. So u e to the 2x plus 1. Okay. If that's true, then what is du? It's 2 e to the 2x dx. Is that right? Okay. I kind of dig that, I think. I think I dig that. I think I do. I think I like that. We'll find out, I guess. No, I don't care for that at all. Just a minute. One moment, please. I was getting excited, then I think I blew it. Just a minute. Yeah, I got a little ahead of myself, didn't I? You're like, Groom, you big dope. You cannot make this e to the x out of e to the 2x, you idiot. It's hurtful, but you're right. It's hurtful, but I feel like you're right. Well, what am I going to do, Groom? I just don't know what to do. Well, here's an idea. We could foil this pig out, couldn't we? I'm just saying. Could we? Well, I feel like we could. And so this would be e to the 2x plus 1. E to the 2x plus 1. E to the 2x plus 1. So if I FOIL this times this, I'm going to get e to the 4x. True that? And this times this is going to be plus 2 e to the 2x's plus 1. And then I can FOIL it again with this cat. And so this times this is going to be e to the 6x plus e to the 4x plus 2 e to the 4x plus 2 e to the 2x plus e to the 2x plus 1 times e to the x. Now all I'm doing is just foiling because it's making my life easier. Now a whole lot I can do this problem. So it's going to be e to the 7x plus e to the 3 e to the 5x plus 3 e to the 3x plus e to the x. Now, if you antiderivative this, you're going to get 1/7 e to the 7x plus 3/5 e to the 5x plus e to the 3x plus e to the x plus c. Nice. How do I know that's the way to do it, Groom? Well, you can always brute force it, kids. You can always brute force it. But my only thought there initially was, it doesn't look like one of my arc tangents, arc sines, etc. Obviously, that's not it. I could try a substitution. That didn't work. Well, now I'm kind of screwed. Now, later on, is there perhaps a different way? Not for that problem, but yeah, perhaps later on there is going to be other methods. Again, you need to recognize patterns and go, oh, that's how I'm going to do this, fella. Okay. Now, in the perfect world, let's say computers had been invented millions of years, well, not millions of years ago, several hundred years ago. Why? A lot of these things would never have been actually done because there had been no need to actually do it, right? Because you could have just did it. You could have, what's the word I'm looking for? You could just use a computer to solve all of them and you'd have been done. And it would have been that easy. Okay. But now, we have to kind of go around out of our way to do things here. Okay. Yeah. Cool. All right. I think that's about what I wanted to chat about today. I feel like maybe we'll do one more. Groom's going to earn his key. I was going to say it's only been 20 minutes. Let me back up. All right. Let's say you want to do this, fella. You see this guy in a dark alley. You cross the street, Groom. That's probably a good idea. Now, Groom, do you see any functions in a function? No. Yes, you do, silly goose. This is tan theta to the 7th power. And this is, of course, secant of theta square, obviously. So do I see a function in a function? Yes. So what does this scream to me? Well, this screams, now my hearing aids are turned on, it actually screams, hey, let's use substitution. And you're like, okay, cool. Let's let u equal somebody. Okay? If u equaled somebody, then du is going to be the derivative of that somebody. Now, obviously, it's going to either be u is tangent or u is secant. Either one would work, technically. However, this one here is the way I would go. Why is that? Because du is what? It's secant squared theta d theta. That right there is du. And what is this then? This becomes u to the 7th power. And so I get 1/8 u to the 8th power plus c. Or in other words, 1/8 tan to the 8th of theta plus c. Groom, could I have done it with secant? Probably. Probably. You gonna try it? I'm always game. Let's do it, babe. What is the derivative of tan? What is the derivative of secant? Well, it's secant theta, tan theta, d theta. So right here I have secant, and then I've got a secant and a tangent. But then I've got 6 tangents left over, and that's just freaking weird. You with me? So this part right there is my d theta. That's my theta, or my u rather. This is du. That's u. Yo no sé. Could you do some dorking around algebraically to get here? Maybe. Do I want to do it? Sure don't. Thanks for asking. Appreciate you helping me out there. No, I don't want to do that. And so I'm not going to. Thanks. Thank you. And correct. So that's kind of the game there. Don't panic or be weirded out about it. That's just what it's going to be. Now, we are going to be doing in the next chapter, after we get done with the next test, which is coming up soon, we're going to be doing what is called integration by parts, which is one of my favorite things on the planet. Okay, that's a lie. And so we will be doing that. That'll be a fun time. There's a few problems on this page of homework that I didn't assign, but I didn't assign them for a reason. The reason I didn't want to do them is because you don't really know the tools yet. Okay, that's the game. So I will see you on Friday if you're lucky, and you have the rest of the period to work and chillax, and have a great day. Bye.